The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to Lab Manager's Product Spotlight webinar series. I apologize for the slight delay, but we had a technical glitch that prevented us from coming on. But here we are. I'm Tanuja Kopal, contributing editor for Lab Manager, and I'll be moderating today's webinar, where we will be talking about titration systems and software and how you can choose the right titration technique to match your application. The webinar today is sponsored by Metrohm USA, and we will be joined by the company's titration applications and product experts, George Porter and Frederick Fiddler, who will be discussing the recent trends and innovations in titration-based analysis. Frederick is the Director of Technical Support and manages Metrohm USA's Applications Lab, and he's really their go-to guy for titration analysis. George Porter is the titration product manager, and he works closely with the R&D and the applications teams to ensure that the systems stay innovative and ahead of the curve. So welcome, gentlemen. As always, our goal is to keep things very interactive and to provide you with an opportunity to pose questions and have them answered in real time. So please feel free to send along any comments or questions anytime during the webinar by typing it into the question box that appears on the right-hand side of your screen. We will begin addressing your questions after our speakers have given their talks. Today's webinar will also be available for viewing on Lab Manager's website, which is www.labmanager.com. The webinar will be archived for at least 6 months, and the website also hosts a number of resources such as technical bulletins, application notes that you may find useful. In our closing slide, we will also share with you the email addresses of our speakers so that you can reach out to them for a copy of their slides or for any guidance on this topic. So without further ado, let me turn it over to our first speaker, George Porter.
Thank you very much, Tanuja. My name is George Porter. I'm the Titration Product Manager with Metrohm USA. I'd like to talk a little bit about the history of titration at Metrohm first, give you a quick introduction to our company if you're not familiar. Metrohm has been in the titration business for 55 years now. We are the primary innovator in the titration instrument industry. Metrohm has created the first automatic burette, first solid-state pH meter, first combination electrode, first recording titrator, first automatic titrator, and the first and still only top-down dosing, and first intelligent burettes, intelligent electrodes, and fully intelligent titration systems. So we'll start out real quick with a quick review of what is a titration. Titration, definition-wise, is to determine the concentration of a substance in solution by adding a known amount of a reagent of known concentration. And you add that amount of known reagent to a point where the reaction is balanced between the two things. And this is known as the end point or the equivalence point. And where is titration typically used and why? Well, titration is used because it's a rapid, exact, and cost-effective technique, and it's really used in nearly every industry and laboratory. It's one of the first things you learn in high school as you're learning about chemistry and how to analyze things, and it's continued to use throughout industry thousands of times every day. Some of the things we'd like to test are moisture content, acid number, acid value, alkalinity, chloride number, epoxy number, amine number, free fatty acid, peroxide value, iodine value, and there's many, many others. And one of the salient parts of today's conversation is how do we see the endpoint of a titration? And it's really we're looking at traditionally either the color with a traditional color change indicator such as phenolphthalein, where you just take it to this very, very pale endpoint, or we look for the change in electrical potential of a solution. We measure the millivolt potential in a solution with an electrode. So, and that results in the classical titration curve. And the other thing that we can measure is change in ion concentration in solution. For example, we take the negative log of the hydrogen ion, which gives us pH, and that's one of many things that we can measure directly. But these are all the classic ways. They're very well defined. Most are pretty robust. But there are some drawbacks to these. For example, if you have very polar and non-conductive solutions, electrodes not very effective or impossible to use. In a solution that's darkly colored or has lots of turbidity, color endpoint can be difficult or impossible to see. And manual titrations rely heavily on subjective evaluations by the user, and it's not readily replicated from person to person. So that can give some bias depending on who the user is running the test. And so, there has to be some better ways to do this. And it's one of the things we want to talk about today. Rapid sensor technology. Really, a lot of what we're doing, we're focusing on advances in sensor technology to supplement and replace the classic potentiometric electrode and colorimetric indicator. We'll talk a little bit about conductivity titration. And here's just an image of one of our typical conductivity titrators. This is our 856 conductivity titrator. A simple layout. We have a computer to control it in this. We have the titrator itself, the little magnetic stirrer, as well as a burette to add the reagent. Conductivity titrations are nothing new. They've been around for quite a long time, but they're getting more and more applicability as a little more exposure now as well. They are excellent for precipitation titrations in general. You can use it as a test of cation exchange capacity, also for determination of dissolution constants. And some particular analyses that we have done more work on, for example, is the alpha acids in hops for making beer, particle size analysis, acid end groups analysis in polymer resins, molar ratio of sulfate ions to carboxylate ions, and pulp charge determination in the craft process of the paper industry. Nice thing with conductivity titration, it's a very rapid analysis because there's no electrode half cell that needs to stabilize, like in your traditional pH type electrode. You're relying only one parameter of the system to monitor and no potentially slow half cell reaction. Conductivity titration curve looks a little bit different than your standard S curve in a titration. It's called what's called a breakpoint, and basically you're looking at your conductivity as your reagent's consumed. It will pretty drastically change in a very defined spot as the conductivity will increase as you have excess reagent. And this is just an example of how simple a conductivity titration. This is our one of the programs we write. It's just a simple flow chart. You just have your titration and calculation. There's usually for conductivity titrations no special extra reagents you're going to add. They're very rapid, very smooth, very easy. Nothing much fancy going on, which makes it also attractive to a lot of people because, of course, the more robust, the fewer parameters that you need for something, typically the better it is to use. And as an example, this is our alpha acids in hops by Conductivity titration. Quick background, alpha acids, which are in place in the hops flour, are transformed into iso-alpha acids during the brewing process. These iso-alpha acids are what gives beer its particular bitter taste, its unique taste. And these are actually standardized. There's an international bittering unit, which is a unit of measure, which is 1 milligram of dissolved alpha acid. And why are these analyzed? Basically, farmers are paid for the alpha acid content of their hops. And they also want to check the efficiency when they extract these alpha acids from the hops to add into the beers. And the hops products themselves, breweries pay on the alpha acid contents. The more alpha acids, the more breweries are willing to pay for that product. And they also need to know the exact alpha acid content so they can make a consistent product with varying hops. And hops are a natural product, and depending on growing seasons and locations, you're going to have varying levels of these alpha acids. So they need to know how to make sure their alpha acids are proper. These different alpha acids are actually being used more and more in the pharmaceutical industry, and have to be a little more specific now with these. Unfortunately, titration is not a suitable technique for that, and you really need to go HPLC. So here's just the principle of the Conductivity titration. You have a combination of humulone, which is one of the two alpha acids, plus lead acetate, which creates humulate. And it's very, very simple. You do an extraction from the sample of the humulones, and that's typically done with toluene. And And you have an aliquot of this extract that's dissolved in methanol. You titrate it with the lead acetate, and this forms lead salt. So basically, you're going to be consuming all of these lead salts that are not very conductive when you have the humulones or isohumulones in solution. But as you have excess of this at the end, when you've consumed all the humulones, your conductivity is going to increase, and that's the end of your titration, and you can do your analysis from there. Fresh hops, the results correlate exactly with the alpha acid content of the sample. But if you have poor hops that are getting old and oxidized, the aging components will distort the result of the analysis, which will actually give you an indication that these are aging, because it does the oxidized components don't react in the same way, and this is also can tell someone has old hops that have been sitting around a warehouse. And these are actually all written into several international brewing standards. It's called EBC, which is the European Brewing Convention. And these are all standard methods. So basically, anything for A and B, these are different extractions. These are all the similar parts of these titrations, and we have all these available if you require them. We have methods for these. And for the bottom of the C, those are for the exact extracts, for example, used more for the pharmaceutical industry for doing it by HPLC. And thank you very much. And I'm going to hand it over to Frederick Fiddler, who is our technical director, runs our applications lab, and he's going to talk to you a little bit about thermometric titration.
Hello, everyone. This is Frederick, and today I'll be talking with you about thermometric titration and what are the advantages of using thermometric titration. Now, some of the key advantages of thermometric titration is that it's fast, it's reliable, and it's easy to automate. A typical setup is shown here with a computer connected to one of our thermometric titrator with dosing devices connected and an automated system. Thermometric titration is not new. It's been around since the 1920s, but it's the recent advances in the processing and hardware capabilities that have made this methodology a rapid and reliable one. So what exactly is thermometric titration? Thermometric titration uses a chemical reaction just like potentiometric titration. So the same equations that you would write for potentiometric titration is the same that you would write for thermometric titration. However, in a thermometric titration, we're making use of the heat gained or lost during a chemical reaction to indicate the endpoint instead of the electrochemical or color change endpoint in a potentiometric or color indication and titration. Now, a basic thermometric system is comprised of a titrotherm base unit and an automated burette connected to a computer. And again, the picture to the right shows you a typical system and can be used independently of the automated system that is shown. Now, one of the key portion of the thermometric system is the thermometric probe. The thermometric probe, it's a sensitive thermistor. It's very rugged. And here in the picture, you're seeing the lower portion of the thermoprobe. And the key portion is the small black portion in the center of the probe that's shown here. It's an intelligent sensor with integrated traceability functions. So once this probe is connected to the titrotherm system that is connected to the software, it brings over all the information regarding that particular probe. It's matrix insensitive, so no reference port or pores are there to be clogged during the titration. So when compared with a potentiometric titration probe, for example, a typical electrode, when used in difficult matrices, we're normally concerned about clogging of the diaphragm, but that is not a concern when dealing with the thermometric probe. as there are no openings or no probes, no pores to be clogged. Now, one of the key features of the thermometric probe also is the fast response time. The response time of a thermometric probe is less than 3 milliseconds. And this is very, very important because what we're doing in a thermometric titration is that we're measuring the heat generated or heat loss during the titration. And so this has to be a very fast response time in order for us to be able to gain that critical information and be able to accurately indicate the endpoint when we're at that point. Now this chart shows a typical thermometric titration, and the red curve that you're seeing is an exothermic reaction. Now as the titration progresses from left to right, you'll see that the heat is generated, and that is indicated by this increase in heat or this increase in the slope of the curve. At the point where all the analyte is neutralized, we have a break in that curve, and that is what indicates the endpoint in a thermometric titration. Now, conversely, if we were dealing with an endothermic reaction, we would likely see that that curve would go in the opposite direction. So we would go from a high to a low temperature, and at the endpoint, we would see a break in the curve. Now, I'd like to look at a case study that was done here at Metrohm, USA, just to emphasize some key points about the thermometric titration. In the case study, we did the salt determination in the spice mixture. Now, this spice mixture was provided by a customer that was interested in the sodium content in that product. Chloride determination was no longer the appropriate method for them, as they needed to know the direct sodium content, not expressing the sodium content by determining the chloride content, which is the conventional way of doing salt determination. Now, the chemical reaction that we made use of is shown here, where we have aluminum ions reacting with sodium ions, potassium ions, and fluoride ions to form a complex. This is an exothermic reaction, and as you'll see here, the sodium can be the limiting reagent once we have everything else in excess. And in a typical titrotherm determination, what we're doing is we're using a complexing reagent that provides an excess of fluoride ions, and we're providing a titrant that contains both potassium ions and aluminum ions. And that is shown in the titrant here, which has a 0.5 molar aluminum nitrate and 1.1 molar potassium nitrate solution. So our titrant is made up at the correct ratio so that we have the right number of moles of aluminum and potassium ions, and we're providing fluoride ions in excess so that the limiting reagent is now the sodium ions. Now, a typical standardization of our titrant is shown here, and you'll see that the blue line represents the exothermic titrotherm curve, indicating the breakpoint here, and the pink curve that is shown is the second derivative, which is what the titrator uses to determine that endpoint. Now, for the recovery of a sodium chloride standard, here you'll see that we got a 99.5% recovery of a typical certified sodium chloride standard that was used to verify during this case study. Now, for the analysis of the actual mixed spice sample, here we did 5 determinations, and our RSD is shown here of 0.63%. Now, in this particular spice sample, the only source of salt in this spice sample was sodium chloride. And so we also used the conventional method, which is the potentiometric determination of chloride, to express the sodium content also. And our values that are found here, which is 30.51%, coincided very well with the potentiometric indirect determination of sodium. Now, potassium chloride, the question is always there, will we have any type of interference from potassium ions in solution? Or if we have an excess of chloride, is that a concern? And here we also extended the study by spiking a potassium chloride solution with sodium chloride and investigating what our recovery was. And here it shows 97.49% recovery in this spiked solution. So in potassium chloride solution, there's virtually no interferences at all, and we're able to get our sodium content determination accurately. Now, I'd just like to quickly go over a few key thermometric applications. One, which is the case study that I just reviewed, is sodium in food samples, sulfate in liquor and granular fertilizers, for example, in the phosphate industry, phosphate in liquor and granular fertilizers, the Bayer aluminum or Bayer liquor determination, free fatty acids, total acid number and total base number in mineral oil products, and the analysis of etching mixtures of plating and solar cell industry. And finally, any reaction that requires a very high-speed stirring, or you know that the reactions are fast, those are typical candidates for thermometric titration. And also if you're operating within a very difficult matrix, and potentiometric titration has been shown to be not well suited for those titrations, then thermometric titration presents an opportunity in those cases. I'll turn it over to George once more.
Hi there, George again. I'd like to talk to you a little bit about our advances in modern dosing technology. Basically, dosing, it's one of these things you don't typically think of that much, and usually if you think dosing, you think dosage with medicine, which is not what we're actually talking about. In titration, dosing refers to the measured and precise dispensing of titrant. And you really can't have a great titration if you don't have great dosing. So you need to have a way to dispense your liquid that is very precise, at the correct speed for your titration, and can have very, very repeatable small increments. So here's the typical layout for your classic automatic burette. This was originally designed by Metrohm in the 1950s. You have liquid that's aspirated into a glass tube, which is represented by the dark color here. There's a change in a stopcock position, and the liquid is then dispensed by moving the piston upwards. Very, very simple design, very robust. It's been used with lots of success. And then by measuring the distance traveled by the piston, and knowing the circumference of the tube, of course, we know the exact volume that is delivered in a very, very precise way. And one of the very, very nice things about this layout is the flow of liquid stops instantaneously when piston movement is halted. That being said, there are a couple drawbacks with this design. The big error that we have is if there's bubbles trapped in the burette, which can happen if you have something that degasses during aspiration, or maybe a loose fitting somewhere. It does happen. And the problem is that these were trapped in the burette, and they'll be dispensed as a liquid because they do take up volume, and this can cause, or will cause, a bias in the results. So it will be dispensed just as part of your liquid, and you'll not have the accurate volume dispensed. Another thing that can happen is if you have a highly corrosive or abrasive reagent, that can cause channeling in the glass that's around the piston. The pistons are made out of Teflon, so there's not much that actually reacts with them. But there are some things that do react with glass. And when this channeling happens over time, basically what can happen is gravity will work against you, and this always will happen to you at the most inopportune time, or over the weekend when you're not in the lab. The reagent will start to move around the side of the piston and drain down sometimes into the instrument or all over your bench top, causing anything from just a mess to clean up to some significant instrument damage. And Additionally, at the top of the cylinder right here, there's a significant dead volume. So this is a titrant that's not dispensed out at the full piston stroke. And this is really because of the design and the shape and how it works. But this can make it so any kind of using this device for any type of advanced pipetting or liquid handling is not very practical because you're going to have some mixing effects there. So what Metrohm has done, we have what we call the Docino. And we've really changed the orientation. It's still a motor-driven piston the concept's the same, except now, instead of having the drive on the bottom, we've miniaturized the motor and moved the drive up to the top. And so the nice thing with this, the reagent is aspirated through the bottom, just straight up, so it's a much more linear and straightforward fluid flow to a near zero volume stopcock at the bottom of the cylinder, so you don't have a lot of dead volume. And basically the liquid's then dispensed down through the side of the burette. And this has given us a lot of different advantages over the classical system. One of the biggest of these advantages is if there is a bubble aspirated, it will not be dispensed. If you notice this, if you look closely here, the shape of the piston on the Docino is a cone. It's a truncated cone, which means it's clipped off at the end, versus the cylinder that's in your classic burette. Now, when this is designed, the max volume of the burette itself, the max dispensable volume, is right at the tip of that cone. So if you have any air bubbles, they'll float to the top to where the piston is, and they'll be in this non-dispensed space. So they won't get dispensed out because they're not floating to the top of the liquid. So they're floating to the top and just being held there by the piston. They just don't get squirted out, which is very, very nice. So just like that, and they'll stay in your cylinder. And the nice thing is this has given us, because we don't have a lot of tubes with this stopcock that's being used now, we can automate any of the preparation and filling and cleaning processes of the Docino itself, of the burette itself. So these air bubbles then can be evacuated during a system preparation step, and you're ready to go, and you don't have to worry about air bubbles accumulating. Additionally, if there is a leak, which does not happen very commonly with these systems, the reagent's going to drain straight back into the bottle, which is one of the reasons for this orientation. Really, it's obviously not as hard as an instrument, and it's also a lot safer for your lab. And another big advantage is this system is half the footprint of the original design. You can readily fit two of these in the space where you'd fit one of the old burette, which in today's lab, it saves us a lot of space, which is always a premium now, as well as gives you more room to do more things. So you're not limited by the size of your system with adding dosing onto it. And this has also given us, with this near zero dead volume and this very, very precise controlled liquid, it's letting us do some more advanced dosing applications. So instead of just using a burette to add our titrant, which is of course still a primary use for it, we can do a few other things. We do it with the titration, of course. We're also, one of our big things, we're doing automatic dilution and dispensing of samples. We have, with our automation that we have some customers who actually use this for doing large amounts of just sample dilution with no titration or other measurement involved, just for sample prep for other techniques. And then, of course, we use this for addition of standards, internal standards, not only in titration, but also with voltammetry and our ion chromatography product lines, which gives a nice unattended way to have very, very well controlled analyses. And another one, last but not least, we have automatic exchange of reagents and titrations that require a sealed cell. And that's really in our Carl Fisher moisture analysis. And we do this quite a bit. And this is a very, very nice way so you can have a large number of titrations running totally unattended overnight, and you don't have to worry about someone babysitting the system just to switch out the reagent. And I'm going to give control back over to Frederick here so he can talk some about our advanced titration control.
Hi, this is Frederick once more. I'd be speaking with you first on the touch control system. So we have a touch controller that is called the Touch Control 900, and its sister is called TI Touch, which is a combined version of the touch control with a titrator. I'll also be looking at the Tiamo 2 software. So I'll start off with the touch controls. Here you're seeing a diagram. You're seeing a system consisting of a titrator, a stirrer, and another stirrer on the other side, and it's been controlled by a 900 touch control system. Now to the left, you're seeing what is called a T-Touch, which is an integrated version. So it's equivalent to this entire portion of the system all combined into one compact system. Here you're seeing the touch control portion, and the rest of it, which is the titration system, is in the remaining portion of that box. And the key thing is that the Docino sits on top of that particular unit, so it's very good from a space-saving standpoint. Now, the advantages of the touch control system is that it's a robust and compact design. It's easy to read. It has full color display. Multiple user login can be configured on the system. And it has direct access to most common commands through shortcuts, which are called favorites, that can be created on the main screen of the system. It's easy for you to integrate the system into your Ethernet, or for you to integrate it into your network, or to use a USB memory stick to collect your data. It's compatible with a broad range of USB printers. This is an actual display of a picture on the 900 touch control, and as you can see, it has a very high resolution. The touch control can be adjusted to different angles so that you can better view the display. At the back of the touch control, you have a port for connecting your USB memory stick or your Ethernet cable to your network, and you're able to control your titrander from this controller cable, and this is where you turn the unit on and off. Now, the touch control has a built-in network functionality, and that allows you to be able to save data or export and import data from your shared directories on a remote computer. You can print to network printers. You can have automatic data transfer to another software that we have that is called the T-Base, that I will review briefly at the end of this presentation. You can also have information emailed from different determinations that are being done at the system. You can also have system backup onto your USB device. Now for the USB interface, we have method and determination files that can be transferred to the USB stick. We can connect a USB keyboard or USB mouse, USB printers, or adapters for connecting your RS-232 devices such as balances. Now the quick access keys or the favorite keys are shown here, and this is the front display of the Touch Control 900, and what you're seeing highlighted are tabs that are configured with methods so that you can quickly access these frequently used methods. So at one click on any of these tabs, you're able to load those methods and automatically start those methods. Now for routine tasks, on a routine basis we have to prep systems. So if your system was sitting over the weekend, or if you put on a new bottle of titrant, for example, you need to be prepping your system. All those tasks can be programmed into a favorites tab, so that you click once and those activities are automatically carried out. Now for system functions, we have the ability to go into the configuration of the system, to manually load different methods, set up different work lists, for example, view our results, or further edit or different methods. Now, finally, the layout of the touch control can be easily customized on a per user basis, so that when different users are logged in, different interfaces are shown. Now, PDF generation, if you are connected to a network computer, you can create PDF files, or you can send those PDF files automatically to your memory stick. Now, the Tiamo software. Earlier in George's presentation, he showed you flow charts that were basically snapshots of the method structure from our Tiamo software. Now, the Tiamo software, it's an abbreviation where the TI stands for titration, the A for and the MO for more. And in some languages, or in another language, Tiamo also means I love you. And once you've experienced the software, you will love the way that it operates with your titration system. It's a robust software, and it's easy to learn and use. This is a display of a typical workplace in our Tiamo software. And here we're showing duplicate titration. And these titrations are running simultaneously. Here at the top portion, you enter the information about the titration that you're performing. So you select your method, put in your sample size, and other important information. And on the lower portion of the screen, here you're seeing the actual display of the titration curve. And to the right, you're seeing an overview of the active method that is running. And you're seeing the same shown on the right for the other titration that is in progress. Now, this is just an example of the display that you can have in the Tiamo software, and it's freely customizable depending on what it is that you would like to see during a typical titration. Now, the layout of the program is just like a flow chart. So it goes in a logical manner. So if you can think of a sequence that you would like the hardware to do, you can easily create a flow chart or a method that takes you through step by step and execute those steps. Now, the Tiamo database. The data from each analysis is stored as a record in the database specified in the method. So each time you run a method or run a sample, an individual line item is entered into your database, and you can click on the individual result files and get all the details about that particular run. You can also reprocess data in the database by right-clicking on each result file and reprocessing, changing sample size, and changing certain aspects of your method so you can see what might be optimized for the next run that you're going to be doing if you're doing method development. Now, database record details. When you highlight a record in the database, it gives you all the information about the particular calculation that was used. In addition to that, when you're looking at the entire database, it's very easy for you to do quick filters. So if you're interested in seeing all the QC samples that you've run historically, you can use our quick filter function to get your database showing only your QC data that you've acquired over X period of time. In addition to that, you can select an entire block of data in the database, and you can export that to your LIMS system, or you can print those determination files to your network printer. Now, the T-base software that was mentioned earlier can be used to acquire data from our T-touch or our touch control systems. And the interface that you see when you look at a T-base system is identical to what you see in a Tiamo software. So the same functionalities that you would have in a Tiamo database, you can also have in the T-base. And it complements a standalone system quite well in that you can automatically have your data sent over from your touch control system. In addition in addition to having that automatically connected to a network Ethernet cable, you can also manually take your USB stick with your data and import it into your T-based systems. Now I'd like to turn the floor over back to George as he'll do a quick overview of some of our Metrohm products.
Hi again, this is George. Just wanted to thank you all, first of all, for coming to this presentation. Hopefully you learned some good stuff from it. And I just wanted to review just some of our products. You can, any of the items we just talked about, you'll be able to go to either the Lab Manager website, as we mentioned earlier, to get a copy of this presentation. You can also go directly to metrohmusa.com, or in the United States, or metrohmca.com in Canada. And you can find more information on these applications, products, and more. You can also follow Metrohm USA on Facebook and Twitter. We have some different information there, so information about different trade shows and other events we're going to. Some occasionally have a little special contests and additional information. Just real quick, just want to look at just a couple more products. I'm not going to go through each one of these slides in a lot of detail. We have our potentiometric titrator line. We have our titrandos and our T-touches, as well as our Titrino Plus, which are entry level. We have some Carl Fisher titrators, including the KF Titrando. It can do both fluometric and volumetric Carl Fisher titrations. So you have a full range from very low ppm up to 100% water, available to be analyzed with one single unit. We also have the T-touch in a Carl Fisher mode as well. And we also have a Carl Fisher Titrino Plus. We also have a full line of Carl Fisher kilometers, which are a compact little titrator that can do low levels of moisture analysis. And we also have, which we was featured earlier, the 859 Titratherm. It's a really neat instrument that really like people to consider this technique more. It's a new and unique way of doing titrations, and it's amazingly fast and very easy to use as well. And just you guys probably have a few of these sitting around your lab, some of you guys attending. We have the Titrino line of titrators, which was our previous generation. And also we have our PSM series, our 600 series of titrators that date back from the early 80s up into the early 90s. And just so you're familiar with the different Metrohm instruments, and we have instruments that go back into the 1950s. And some that are actually, believe it or not, still working in our customers' labs. And you can stay tuned to our website to find more about some of these neat old titrators that are being used at our customer sites. It's pretty amazing. And thank you very much for coming. Here's our contact information, and I think Tanuja is going to open this up for some questions now.
Well, thank you, George, and thank you, Frederick, for a very nice tag team presentation. For those of you who may have missed my opening remarks, I just wanted to remind everyone that the webinar will be available for viewing on Lab Manager's website, and the link to the archived webinar will be emailed to all of you sometime soon. The email addresses of the speakers are now shown on your screen. So please feel free to reach out to them if you're looking for a copy of their slides. And thanks to all for sending your questions. We will be addressing those shortly. If you have any other questions, we have about 10 or 15 minutes to go over your questions for you. So let's begin with the questions because we have quite a few of them that have come in. Let me start with the first one, which is, what factors really influence the results or cause variability? Would something like temperature actually affect results, the titration results?
Was it specified what type of titration we're talking about?
Yeah, this would be the thermometric titration.
Okay. No, I'm assuming that the question is aimed at ambient temperatures, and this is a very fast technique, and so a typical titration, we're doing that within 60 seconds to 90 seconds, and we're not, unlike a potentiometric titration, we're not waiting for a response from the electrode, basically. We're just dispensing our titrant at a fast rate, and so the entire titration is completed within a maximum of, let's say, 90 seconds, and so ambient temperature does not get a chance to influence the overall temperature change that we're measuring. In addition to that, the absolute temperature is insignificant. So it doesn't matter if we're starting off at 22 degrees versus 24 degrees. The important thing is the temperature change. And so ambient temperature would not be affecting our titration in this case.
That's really good to know. And about other titrations, are there any other factors that people should be concerned about?
Now, when you're looking at the non-thermometric titrations, actually temperature can be a pretty big influence, especially when you're measuring something like pH, which is a derived unit, and actually temperature can influence actually the pH being read if it's not corrected for. Additionally, there are some other big factors that influence your titrations. We covered a lot of it's the condition of your sensor, the reagent. Basically, if it's been standardized recently or if it's aged and it may have changed concentration. We're doing a controlled chemical reaction, so there are a lot of different influence, including things like stirring speed and even the direction you're stirring your titration. So if you do it clockwise or counterclockwise, depending where your sensor is and your titrant dispensing, it can actually greatly affect your titration if it's not set up properly.
Got it. If a sample contains both thiocyanate and chloride, could you detect both without one interfering with the other?
I'm assuming this is via silver nitrate titration. If that is the case, no, they're going to be showing up as a single endpoint, and we would have to use different methods to isolate this, because what we could do is maybe do the cyanide via a different method and do the total via the silver nitrate titration, and then we'll be able to find the differences. Yeah. Does that address? Yeah.
Yes, probably. And what about the similar question with sulfide or sulfite?
And actually, that's similar. We can actually determine both sulfide and sulfite concentration with different orthogonal techniques. That way, and that's one of the nice things. It's really easy to chain two titrations together, or even two separate techniques. And we see that a lot with our customers. They have multiple components, and these methods are usually rapid enough that, a couple minutes apiece, that you're not using a lot of time to have two separate analyses.
Okay, got it. What is the reasonable detection or quantitation limit for a TAN, TAN, by thermometric titration?
We haven't established the minimum detection limit, but in general, that the thermometric titration, we're not aiming for the very trace levels or the very low end. We're aiming for that that mid and upper range with this technique, because as you would imagine, because we're measuring that temperature change, that heat is going to be very dissipated at a very low content, and so we do not have a clear-cut answer to give in terms of what is the minimum detection limit for all different types of oil samples, for example, right? So that is something that we would have to do experimentally to determine what is the minimum detection limit for, let's say, for engine oils or for marine oils and different type of used oils via this technique. And one key thing is that we would not use a titrant that is a very dilute titrant, and so that adds as an additional limitation as to how low we would go. But if there are follow-up questions that you have regarding a specific type of oils, please send over an email to us, and we'll follow up with you in terms of discussing your specific needs.
That's great, and thank you for mentioning that, because yes, some of the questions that have come in are very specific and very which contain a lot of details about the experimental methods and so on. So we would definitely forward those along to you. And if you can take the time to answer the person back, that would be greatly appreciated.
Okay. We'll definitely do that. We appreciate any questions that we get.
Okay. The next question is, how easy is it really to clean all these automated titrators, especially when you're switching between solvents? And what is involved with routine maintenance and upkeep?
Like any piece of laboratory instrumentation, you're going to have certain routines that you're going to have to do to keep it maintained. But one of the things that at Metrohm we've really strived to do is maximize your efficiency in the laboratory, the time that you do have in the lab. These instruments are made to be very easily cleaned. Many of our automated systems, we have, if not totally self-cleaning, they will do a bulk of the cleaning themselves. We have routines set up to regularly clean your probes, as well as you can rinse your own burettes as well, especially with the Docino technology, make it very easy to set up to clean itself. Additionally, when we're working with different materials, we try to choose ones that are robust for different cleaning types. If you have, working with something like a crude oil or different polymer resins that are very difficult to clean, we like to use materials that will be easier for you to clean. That being said, they are very easy to clean, as well as there aren't a lot of different small spaces, nooks and crannies to really get different, say, your reagents or sample into, because that would actually just also impede the efficiency of your titration if you have a lot of places where things can deposit.
Okay. And with respect to the dosing unit, is it good to keep it empty or filled with water, especially when you're not using it for extended periods, say like a week or more?
For the majority of reagents, there would be no need for you to empty the Docino. If we're talking about typical reagents such as HCl or most acids, for example, or some type of bases, then there's no need to empty. When we would suggest that you empty and refill with water, for example, or just rinse with water and leave empty, would be cases where you have, let's say, one normal or greater sodium hydroxide or potassium hydroxide, and you don't want to be leaving these aggressive bases just sitting there over an extended period of time, because it's just going to be etching away at your cylinder. And that's normally the case with any burette that you're looking at, is that over time your bases are going to be etching away at your glass. So depending on how long these periods are, then we would suggest that you rinse with water and store it if we're talking about bases. But for the majority of solvents and normal acids that are used in typical laboratories, there would be no need for you to do that on a routine basis.
Okay, great. And a couple of people have asked if if they could send you samples, and if you would be willing to run the experiments and give them the results, because they are really concerned about reproducibility and I guess maybe even sensitivity issues. I'm not sure. So do you do that?
Yes, we do. We do have two large labs here at Metrohm USA, and we're able to take in samples for ion chromatography determinations, for titration determinations, and for general electrochemistry determination for the products that we support. I'm assuming that a lot of the requests that are being mentioned here are for a thermometric titration. If that is the case, certainly we can, because a lot of times if you're looking at investigating this technique for new products, you will need to run it to establish what your detection limits are and so forth. We would strongly recommend, however, before sending in samples, that you send an email to us, just so we can give you the proper documentation to fill up prior to sending in these different samples. All right?
Okay, great.
Yeah, and I also wanted to mention, and this is not only for customers in the U.S., but in Canada as well, that or served here through Metrohm USA, the laboratory.
Okay. The next question is, can your Metrohm equipment connect with equipment from other companies? For instance, there's a high. Okay, go ahead.
Oh no, go ahead. Did you have a?
No, for instance, does the high touch station connect with other titration workstations, for instance?
Okay. Our titration equipment does not attach to other companies' instruments, but our Tiamo software is actually able to incorporate other other companies with RS-232 instruments. We can use our software to control and collect data from those. So, we readily incorporate other companies' instruments into ours, but not as much the other direction.
Okay. And is this, the Tiamo software, is the manual available online? That was the other question.
Yeah, if you go to our website, they have a, if you go to www.metrohm.com/com, that's not Metrohm USA, but metrohm.com, there's a full support section for the Tiamo software that does have the a PDF of the manual available.
Okay. And how many equipments can be connected to the software?
To the Tiamo software, it's now actually unlimited would be the right answer. I am comfortable. It's more of a human factor at that point. How many can one person run at one workstation? It's very easy to do 4, or even a few more than that, 4 or 5. Then you're just one of those, like you have a lot of people trying to crowd around one system trying to use it.
Right. That's a good point. The next question is, we see a drift of our standards or factors after a few hours of non-use. For instance, we run the factor and standards and then an unknown and then, another unknown after 3 hours, and we see that the same standards actually have a higher value than it did before. So what do you think is the cause of all this?
I'm assuming that this is referring to a Carl Fisher determination. Was that specified?
No, unfortunately that wasn't.
Okay. Just from the way that the question is structured, my guess is that this is referring to a factor for the Carl Fisher titration, and then sample, and then doing the standard. No, depending on the type of sample that you're doing via the Carl Fisher titration, it could be that we're seeing undissolved sample that is not properly titrated or fully dissolved at the end of that determination, and so there's some carryover to the next titration, and we're seeing an accumulative effect. So that is a possibility. Secondly, it could be that we're seeing a case where we have a dirty indicator probe, and it's very hard to say without delving into a little more detail about what it is that we're titrating, and also a comparison of whether or not we're seeing the same effect when you change out with fresh solution and start new titrations. So if we're to properly investigate this, one of the key things to do would be to clean that entire cell, start with fresh, let's say we're talking about a volumetric Carl Fisher, start with fresh methanol. If we're just talking about the general KF volumetric, start with fresh methanol, perform your conditioning, perform your factor method, perform your titration of your standard, and that should have no carryover because we're talking about a water standard that is in solution. You should be able to get accurate values there and go on to do one standard, or one sample, I should say, and then clean that entire vessel and just do a new sample, clean your vessel, do a new sample, and if we're not seeing that same accumulative effect, then that is clearly going to be indicating to me that what was causing the problem is that we're having undissolved sample that is causing an accumulative effect over time.
Okay, appreciate that, Frederick. There are lots more questions that have come in, but I hate to say this, but we have run out of time. And what we'll do for those whose questions are yet to be answered, we'll just forward them along to both George and Frederick. And both of you, if you don't mind, do take the time to review the questions and try to get back to as many people as you can possibly.
Yeah, we'll get back to everyone who submitted a question.
Okay, wonderful, wonderful. Thanks a lot. So again, just a reminder, note down the email addresses for our speakers which appear on your screen. They will be able to share a copy of their slides with you. We will definitely be forwarding the questions that you've already sent in, but if you have additional questions or guidance on this topic, I'm sure they'll be able to help you out as well. So on behalf of Lab Manager, I would like to thank Metrohm for their participation and support. My sincere thanks to both George and Frederick for putting in every effort to make their presentation so lively, so informative and relevant to our users. The webinar will be archived on Lab Manager's website. So please visit us online to review this webinar, but there are also many other webinars that we have done in the past years. And if you need information about upcoming topics, you will find that on the website as well. So please take the time to join us again. Our webinar next week on February 23rd is discussing innovations in ultra-low freezer technology. So thanks once again for your time and attention. Until next time, goodbye and good luck.
Thank you.
Thank you.